This meeting of the Warren Astronomical Society. Well, we got more people online than we have here in the audience. So, I'm President Bob Tremblay. Do we have any new members or new people here tonight? Hi there. How'd you find out about us?
Meetup.
Meetup. Awesome. The internet is a wonderful thing. So, we meet. Yes.
What's your name?
I'm sorry. Well, we're gonna do the round. Hi. So we have we meet here third Thursday and first Monday at Cranbrook, huge auditorium, and we have an observatory at Walcott Mill Metro Park. We have a free open house every fourth Saturday of the month. We open it up, and we'll have members come and set the scopes out on the field. It's a good time. It's a very good time. Even if it's cloudy, we can still geek out about astronomy during that. So, let's see. You can watch previous meetings on YouTube too, because we record these. So our talk tonight will be about Nancy Grace Roman, and I'm rather excited about it. I looked at her Wikipedia page this morning. I am embarrassed to say I don't know very much or didn't know very much about her at all. And she probably had a big effect on my life as a young man. So I'm really looking forward to this talk tonight. So as a tradition, what we like to do is we like to go through the ranks and do a roll call. So hi, I'm Bob Tremblay.
Dale Parkman, first vice president.
Dina Long, card carrying member.
Sonny Spilos.
Angelo DiDonato.
Bob Burley, past president.
Pete Lemire.
Carol Strack, bank secretary.
Here.
Hi,
Andy.
Earl. I think those are officially called party crashers now. Yeah. It was you.
Dana Bransky, treasurer.
How do we do this online without everybody going all at the same time?
Brian Wazensky, about a member for 2 years now.
Oh, yes, that is okay.
Bill Slogeris, a member and presenter tonight.
Tom Cervinak, Hamtramck.
Riyad Mati, Observatory Chairman.
Doug Bach, a fossil from the past.
Dale Tamey, a fossil from the present.
Current fossil. All right.
Does that mean they fell out of the sky like a meteorite?
Yeah. I'll be getting to that. Okay, so we have two new people. Hi, who are you?
So
And
Tim Scott.
and did you are you new? Have you been to here before? Hi there. How'd you find out about us?
Awesome. And I kind of surprised her with.
Awesome. Well, thanks for coming. And we said we usually do the roll call as we start the meeting here. So, okay. So, if anybody wants a lanyard, does anybody have a lanyard on right now? Yeah. If anybody wants one of those, you can contact the board or publications and get one of those. Let's see. Mailers have gone out, so it's time to renew your membership. I did online via PayPal today. Cranbrook on the 25th is having a planetary alignment event. We have several volunteers who have volunteered to bring their scopes and stuff. Get there before dark. And I haven't got any confirmation from Mike Narlock what's going to happen if it's cloudy, but we have people show up at Stargate all the time. So, I mean, I'd be willing to give a presentation. I told them that. So I'll let the membership know about that, but I plan on being there then. So do we have any calendars left? David?
I don't have any.
Anybody have any calendars? Oh, our astrophoto calendars are all gone. Oh, well. So we do every year we do a calendar of photos from the membership, and they're very cool, but they finally got sold out. So WASP wearables like t-shirts and stuff like that are available in our newsletter, which is online. Our annual picnic date has been set for August 23rd, Saturday, August 23rd, probably 4 p.m.-ish. Our GLAC, the Great Lakes Association of Astronomy Clubs, met on Monday, and I was there. We're switching it to Tuesday One of the problems is me. I miss GLAC meetings occasionally because our meetings coincide. So Tuesday, moving it to the second Tuesday of the month, the GLAC board would like a couple members from the member clubs to attend these meetings. And Jeff McLeod has said he's interested, so I could use another member. The meetings are online via Zoom. So elections were held that evening. Tim Campbell is president, and some officer positions are still required. So, GLAC puts on Astronomy at the Beach, which is an event in September 26th and 27th this year. We're just starting planning, so we don't have speakers or anything like that. So if you got ideas, let me know because we're looking for them. So officer reports, really quick. Please keep the thousands who have lost their homes or worse in the California fires in your thoughts. Steve Collins, someone I know from JPL, lost his home, as have hundreds of other JPL employees. That's pretty awful out there. The Vatican Observatory has announced its 25 international students for its 2025 summer school in Rome. They'll get a comprehensive overview of the major James Webb Space Telescope results in its first 3 years and receive a series of hands-on tutorials for JWST data processing and analysis. Several members of various JWST imaging teams are instructors, and the Vatican Observatory Summer School has run almost every other year since 1986, and several of those students have gone on to do amazing things. I know one of them is the head of the European Southern Observatory's Science Directorate. And another one, Heino Felke, he was part of the team that took the first image of the black hole. So pretty cool program, and I wish I would have known about what I even got. But it's cool that they do this. They had 25 students. They had 140 people sign up. Wow, it's cool.
The kids?
They are pre-PhD, heading toward their PhD.
They're college level.
Yeah. And
All over the world.
all over the world. They had, let's see, I don't have the list here, but at least 2 from Africa. Oh, 2 maximum per country. And so
Wow.
all from many, many different countries. So Dale, I know what he's going to say.
Surprise, surprise, I could use more speakers. In particular, at our next Cranbrook meeting, we have our main speaker that will be Dennis Conti, speaking on the wacky world of exoplanets and how we discover them. But I do not have a speaker to give a short presentation at Cranbrook next month. So that means it'll be me, unless somebody else wants to step forward, preferably tonight. And then a month from now, back here at Cranbrook, I'm back here at Macomb. The speaker will be John McGill, who's heavily involved in the Ford Astronomy Club. His title will be Up Close and Personal Rocket Launch Photography. His big thing is going to these launches and doing his own photography, video, and so forth. He really likes doing that, and he'll be sharing some of those experiences with us. Not only what he sees, but what it's like to go there and try to do that. And I need more speakers for future months. Although we're in pretty good shape until May, other than I need a short speaker for the next Cranbrook meeting. So if you got an idea, something you could put together, let me know, preferably tonight. Thank you.
All right. All right. Dale's our first VP in charge of getting talks, and he needs talks. So Riyadh is our second VP. He's in charge of our observatory. What you got going on, Riyadh?
Yeah, last meeting we had in December, we had a few calls in the clouds. We were able to observe at least a few planets. I after everybody left, we closed about 7:30. And right around 9:00, 9:15, I got a call from Dale Parton. A few more people showed up, so at that point I was too far to get back in there, and he was close and he had his scope with him in the car. So he drove over there and helped out. We had, I think, an additional maybe 12 people or so that showed up late because of what they read basically is in Wilcott Mills is that we had an open house that starts at 9:00 until midnight or something like that. So
Yeah, they changed that actually. It says
Good.
dusk now,
Yeah,
so that'll be
right.
better.
good. I also left a note on our display cabinet outside the observatory that says the same thing, that the observatory's usually open houses are on the fourth Saturday of every month. And they start at dusk and go for at least 2 hours if it's cloudy and nobody's there. Otherwise, we'll be there for longer. So speaking of that, our next open house is coming up on the 25th of January. So hopefully we'll have some clear skies so we can see all these planets on the ecliptic. Everybody's saying that on TV that there's an alignment. I mean, the planets are always on the ecliptic, so they're not
They're always,
like
yeah, Jeff McLeod said that. They're always on the
Yeah.
same line. They're just not always in the same part of the
Exactly,
sky.
exactly. So, but anyways, if it's clear, hopefully we'll be able to look at the planets, but also do some deep sky observing and look at some double stars. So, come on out, even if it's cloudy. Now, if the weather is really bad and it's dangerous to drive, then we may cancel it or do not drive under bad conditions. But otherwise, yeah, I'll be there for at least a couple of hours, starting at 5:30. See you then. Thanks.
All right, thanks, Riyadh.
Outside of the Cranbrook.
All right, Treasurer David, what's up in the Treasury?
All right, so as of today in our checking account, we've got $23,184.27. Nothing due on our credit card. PayPal, we've got $768.86. Our cash box, we've got about $500 and some change. And that's it.
All righty, thank you. Charlie, Secretary, what is up with the minutes and everything else?
Hey, good evening, everybody. And this is Charlie Strackvine, Secretary of this fine organization. And I have to report, there's been no incoming mail that's noteworthy. And again, if you are interested in a fancy name tag, please just notify the board and see myself, and I'll deliver it to you. All right, thank you.
Thanks.
All right, Bob.
All right.
Yeah.
All right, Jeff McLeod, are you online? Oh, you're not online. You're live.
Never on
You're not Member X. You're live.
person. I'm not making it on my computer either. Did we already cover Cranbrook?
Yeah.
Okay. The big
Do
one,
it. Do it again.
the big one right now is Cranbrook on the 25th, same night as the open house. So like you said, if it's cloudy, go to Cranbrook, because then we don't have to really do anything. We can still look good. And you'll probably be able to talk to more people at Cranbrook. They are doing inside stuff.
I don't know.
Okay, I'll reach back out to it.
I will poke them to do that. I am more than willing to.
I've done stuff like that a long ago.
Small table something?
I'm sure they do.
If not, I got a workmate.
Okay.
Holding workmate if I have to.
I think we've got 3 telescopes that I can think of that are going out there, but there's no limit. So
Yep.
I will not discourage anyone from going out there.
I would suggest that people who are gonna have telescopes, if you have a little step stool of some kind, so that kids who are short can get up on it.
There will most likely be children. Yeah. Don't bring your nicest scope. Bring it down.
I only have one. My dog.
Yeah, Mark's gonna be there. Tina's gonna help. You're there, and Ken Burton's gonna be there. So we're gonna have a refractor. Who's got a castogram? Anyway,
I have a little one I can
don't
bring.
worry about it. No one knows about those. I'll be speaking to the lowbrows in February. If you're out Ann Arbor way, probably not. Maybe some internet people, but I'm giving my Apollo talk to them. Oh, and then oh, what is their name? It's not the Macomb Nature Center, Sterling Heights Nature Center. I helped them with a little telescope that they got in the 80s and are now starting to use. And they got so excited that they've now bought that telescope new, fully digitized and all that kind of stuff. But they want to do stuff with us. So there's an event
Yay.
in June. So plenty of time, fair weather, hopefully.
Where do they want this event?
It's going to be at their nature center.
Okay.
It's by Hall Road, Sterling Heights.
Oh, that's like right by me.
Yeah.
Cool.
They were really cool. They've got a fun little nature center. I mean, talk about a hidden gem in that area.
Let me know about it. I'll take my granddaughter to it.
Yes, they've got snakes and turtles and
Snakes.
all kinds of stuff. A really cool they've
Sold.
got a huge picturesque window that goes out onto their bird feeders, and the birds are there. So yeah, they got a cool little nature center there. That's all I have on the books. If you know about anything, email me. If you've done anything, email me. Info, board, outreach, those will all get to me. So, all right. Thank you.
I'm giving a presentation.
Oh, yes.
On the 25th,
On the 25th,
7 pounds.
7 Ponds, right? I almost said 4 o'clock. So if you want to see Dale Parton talk about
Don't come to my talk. Go to one of these other things.
latitude, longitude.
My talk.
He's also talking in April, but I'll let you know when the date gets closer.
So for the new guys who might be confused here, there's like 7 astronomy clubs in southeastern Michigan, and they all meet sometime during the month. And actually, one of the things that the GLAC meeting, where the president wants to do is he wants starting to do a lecture share between the clubs, and I think that's a fantastic idea. So yeah, I'm sure you'd love that. I will get you in touch. Okay. Pardon me?
Hey, Bob,
Yes.
Doug online. Now, did you say that the GLAC decided on the September 26th weekend?
Yeah, 26, 27.
That's the same weekend as the Great Lakes Stargaze. Did you know that?
Are you kidding me?
I just looked it up. The 2025 23rd GLSG Star Party will be held from September 25th.
I guess we're gonna have to change that, aren't we? Okay, thanks, dog. I'll let them know about that. Oh, for crying out loud.
Okay.
Good thing we found it early. Good thing we don't have speakers locked in yet. Okay, continuing on. Yikes. Let's say publications, Vichalia, are you online? You here? No. Okay, so our newsletter, Dale Teamy is online. He is there in the upper right. He does our newsletter, which has won an award a couple of years ago. Should probably win an award every year. It's fantastic. Should read our newsletter. It's awesome. So David Levy is not with us tonight. So we won't be doing that. Huh? The WASP is up. Our newsletter is up. So going on to astronomy news, my exoplanet update. Yeah, I'm an exoplanet freak. We passed 5,800. We're at 5,819 confirmed, and we've got 7358 candidates. They added a whole bunch of new data and spectra, but one of the things they did was for a super hot Earth, and I wonder if I can show this here. This is their representation of that. And I'll see if I can share that to the audience. Internal audience first. So this is a super hot Earth. Now take a look at how close it is to its star. So let me see if I can share that via Zoom now. Pardon me? Yes. Let's see, share that. All right, so here's this hot super Earth, and there's the the red dwarf it orbits. That's like super ridiculously close. This app is Eyes on Exoplanets. This is NASA's exoplanet app, web app. You can go to home. You can go to any of these exoplanets and see representations of the exoplanets that we've discovered. Very cool. Share, there we go. So, here are my notes. Here we go. All right. So, SpaceX, yesterday? Yeah, yesterday launched 2 lunar landers, and this is an article from the AP. It's take 2 for Tokyo-based iSpace, whose first lander crashed on the moon 2 years ago. This time, it has a rover on board with a scoop to gather lunar dirt for study and plans to test potential food and water sources for future explorers. And my first thought there was growing potatoes in the Martian. Let you take that thought from there. Lunar newcomer Texas-based Firefly Aerospace is flying 10 experiments for NASA, including a vacuum to gather dirt, a drill to measure the temperature below the surface, and a device that could be used by future moonwalkers to keep the sharp abrasive particles off their spacesuits and equipment. If you've never seen moon dust, it's like microscopic shards of glass. It's very nasty stuff. Really don't want to breathe that. Blue Origin launched its first orbital class rocket successfully this morning after nearly a decade of development. The New Glenn, called after John Glenn, the first American astronaut to orbit the Earth in '62, followed its namesake's trajectory by reaching orbit about 13 minutes at 2 a.m. this morning, liftoff from Cape Canaveral. Booster did not land correctly. I did not see that. And Dale told me about this. I didn't know. SpaceX launched another super heavy, and they caught the booster again, which is crazy.
Lost communication with the ship. Oh, jeez.
So, hey, space is hard. So, impact. A Prince Edward Island homeowner captured sound and video of a meteorite strike on camera, and scientists believe it's the first time 7 grams of meteorite material was retrieved. So, let me show you that picture. There's the impact on the guy's porch. Share that with our viewing audience. This is I was like flapping my hands when I saw this morning. So there it is. That's the impact. So let's see if I can just share this on. Can you see the video here online? All right, so that's freaking amazing. Meteorite impact caught on camera for the first time in a guy's backyard. That is pretty cool. Me being the meteorite freak I am, that was pretty cool. So they recorded they captured 7 grams. There's a guy holding a piece of it. So not a whole lot, but yeah, so that's pretty cool. So, spaceweather.com. I should have just left this over here. This is the sun today. Yeah, it's a lot of sunspots. Spaceweather.com.
I just read the magnetic poles of the sun are about to flood.
Thought I saw that a couple weeks ago, but yeah, we're real close. So spaceweather.com says the sun's been quiet, but these two guys, unstable magnetic fields, harboring energy for the highest class solar flares we have. So this was the image of the sun today. Now, underneath this on the sidebar of space.com, they have a link to remove the numbers so you can just see the sunspots. And they also had Carrington. And I'm like, what's that? So I clicked on that, and there is the sunspot that caused the 1859 Carrington event. It'll be there every time, so you can compare the sun with the big one from 1859, which I thought was pretty cool. This is an image of the sun taken with an Apollo M Max mono solar camera. This is on Facebook's solar activity group. It's a group where amateurs post amazing stuff, but that's just a mesmerizing picture. What you're seeing there are called specules. That almost looks like fur, but that's plasma hairs on the sun, and this is just all over the surface of the sun. But every time I see something like this, I got to think that, the solar astronomers from the late 1800s would have freaked out at these images of what you can do now. And here's the, I don't know if this is going to pop up when I click on it. Yeah, there's the camera. That's the kind of camera. So that's just an eyepiece camera. It's in the price range of the mid 550s to mid 650s.
That's the camera I use for my solar stuff. It's from that same company.
Really?
Different model, but the pictures I get are similar to that. Ours, close up, amazing detail.
Yeah, amateurs can just do amazing solar stuff these days.
The full quarter.
No.
All right, so continuing on, do we have double stars, Riyadh? Still waiting for the Nova.
Yeah. Well, you can't see it right now, but yeah, of course, we're always looking for double stars when we're out observing. And part of the list I sent you the other day, that's one of the standards usually. And also
Thank you for that.
ones, yeah, there are ones that are pretty challenging that also we like to look for. So we'll be looking for them this coming open house.
Okay, so if you're interested in starting a special interest group, say radio, astronomy, computers, technology, education, podcasting, light pollution, great, do it. Let us know about it. We'd love to have something like that. So any observing reports? I looked out the window this morning and said, I wonder if I'm going to see the comet. My wife says, what state do you live in? And then I got to thinking, why does Michigan have so many astronomers anyway?
Nobody visible, early morning or?
Yeah, it was morning to the east.
Yeah.
And I don't know how long it's going to be visible, but from what I have heard, it could be as bright as Venus. Yeah, that'd be cool if it's there. So it is 7:30. It is almost perfect time to take a snack break, unless anybody else has any observing reports. Anybody see anything at all other than clouds? Clouds.
Ice.
The moon, when did you see it?
I think about 7:30 or something. And then I pulled over an 8 Mile and I moved out my telescope to look at it. By the time I got all ready and stuff, the clouds came.
Story of my life. Michigan astronomers have a lot of patience. All right, so we're going to take a half-hour break and reconvene at 8 o'clock for our feature presentation. In the meantime, the guys here are going to take a snack break. You guys can do that too. So come back in half an hour, and do we have snacks? Let's do snacks.
Hey, Bob, how many people do you have there at live?
Oh, dude.
Roughly. Just
14.
enough.
15.
Thank you. Thanks.
By the way, I appreciate the fact that we are keeping Zoom meetings available for those of us who can't quite get there to the meetings.
Oh, you're welcome.
Very
It's
well.
not too horrible to set up, is it, Dale? You pretty much got it down now.
No, that's pretty easy.
For you guys, not for me.
I'm gonna see if I can show this during the break. I need this to shut up. I'm showing an application I just bought the other day for $3 on Steam called Orders of Magnitude. It's like an interactive VR powers of 10. Music, shut up, music. The intro I want to share you now. All right. Setting, music.
I have to stick out a little bit.
Is that, you guys see that? See the Earth online?
Yes, we can see it.
All right, so this is an application called Orders of Magnitude. And I don't know if anybody's ever seen the old Powers of 10 video from 1977. What this does is this allows you to just travel the universe. And let me see if I can stop the fly through and start the flash. There we go.
Yeah.
But this is this works in VR too, which is pretty cool. It's like an interactive VR Powers of 10. 1977. Before CGI. So does this. So does this. But this goes further than Powers of 10 both ways. And you guys are gonna laugh when they get to the edge of the universe. You'll see why. I'm not a fan of the way they're representing the Milky Way there, but you know, it's okay.
Oh, that's why. Yeah.
All right, so here's the visible edge of the universe, Bob. But they keep going. The multiverse, which is total hypothesis. Conjecture. The multiverse is conjecture. So then, now they're way out here, then they zoom back in.
You don't have to dive in. Where can I find that?
Steam.
Steam, STEAM.
All right. Write it down, so I don't want to screw it up.
Yeah, this is the non-interactive fly through, but it's got something you can just do whatever you want.
Okay.
So hours of 10 kind of stopped at the photon. This goes down to the Planck length. And this is called orders of magnitude. It was on sale for $3. I had to get it.
Hi there.
How are you?
Good. Keep them busy. That's why we do this, so we can keep busy.
Absolutely. That's the reason why there's so many astronomers in Michigan and we're the sixth cloudiest state.
Did you hear what I said, though? You know, why are there so many in Michigan? Because we like to travel.
Yeah.
Okay. See?
Good point.
It's like, all right. My cousin lives down in Alabama, and he keeps saying, you need to be down here looking at the sky. He goes, I know you can't see it from up there. And it's like, yeah, I need to pack up my Sea Star and go down to Alabama. Boy.
I'll give them back to you, Cranbrook. The other thing is, I want the little tablecloth name on it, because the thing is my workmate is pretty.
I got two of each of those.
So let me take that one. So that way, if I have to show up with my workmate, it doesn't look so shaggy.
Yeah. I need munchies.
I was gonna say, and because of remember the air show, we had everything blowing all over the place.
Nightmare.
Idea.
Do it inside.
So thinking outside the box. So I have to live up to my award. So, but yeah, when we leave, I want to take I'll take one of the flags and I take the small tablecloth for safe.
Do it again? I don't know what this is doing. Oh. Never actually run my call with a pig. Again.
No, I'll probably buy, yeah. The original from 77? No.
Like that. I don't know if I can. I can't share it online, but I can play it here.
Okay. Well, no, that's fine. Because I'll look that up then, the original color you had.
Yeah, Paulton.
Okay.
Hours of 10 was a video that came out in 1977, created by IBM.
I know of it, I've never seen
Way
it.
before CGI.
Gotcha.
And they did essentially this. They stopped about here. They didn't go to the edge of the universe. Because I don't in 1977 they hadn't seen the cosmic microwave background radiation, so they couldn't put that in there. And so when they zoom in, they pretty much stop at like the proton. They don't go into quarks. And this one goes way past quarks down to the Planck length.
My dad went for IBM. He was a geek, he had a pocket protector. And when it started us into it, I mean, I'm a hacker on the computer from way back when, so it's like, okay. Nope. Whatever time they need tech support, guess whose phone rings?
2-minute warning. Get a drink, catch your bio. Be back in 2 minutes. Meeting starts. Hey, Bill, you want to get your presentation shared?
Question is, how useful is that without model? And is the model truly distributable? And
How does that look, Bob?
it's kind of calling into question how open source definitions even apply to AI.
Bob, you see my screen?
Yes, we're seeing your image.
Okay, thank you.
All right, it's 8 o'clock. Let's get this show on the road, our main presentation. Alrighty.
Are we on?
Yep.
On the air?
Yes.
Hey, guys, we're getting started. Okay. So our speaker tonight is Bill Slogeris, Jr. He worked as a software engineer for 40 years. On his 60th birthday, he gave himself a telescope. That's better than having your kids give you a telescope when it's not, you may not want one, I recently bought a telescope from somebody who was given a telescope by his kids when he retired, and it wasn't for him. But he gave himself a telescope, so he knew what he was getting into. Poor guy. And then he watched tutorials online to learn how to use it. Give him credit for that. But then he found out that he could get help at astronomy clubs in knowing how to use his telescope. I checked the record. He joined this August organization in late 2021. So as he's used his telescope more, he's become more and more interested in astronomy, and he's even exploring astrophotography. And we have people in this club that could really help you with that. Huh?
He's going to be pretty good.
The comment from one of our August astrophotographers is he's getting to be pretty good. And he likes sharing his new knowledge and skills with others. He's a solar system ambassador. Bill's topic tonight is Nancy Grace Roman. Bill, you're on.
Yeah, thank you, Dale, and thank you, Bob Berta, for the recommendation to Dale to have me present the speech. The mother of Hubble, and just a little clarification, this is not about the parents of Edward Hubble, the astronomer. This is about the Nancy Grace Roman Space Telescope, otherwise Nancy Grace Roman, and the mother of Hubble, the Space Telescope. Welcome, Warren Astronomical Society Club members and guests. Very pleased to present this speech and hope you learn a little bit about Nancy Grace Roman and the telescope named after her. So who was Nancy? Well, she was born in May of 1925 in Nashville, Tennessee. Her mother was a nature enthusiast who took Nancy out at night to view the stars. At age 11, she started an astronomy club with her classmates to study stars and the constellations. So she really got addicted to astronomy at an early age. Her education consisted of a bachelor's degree in astronomy at Swarthmore College in 1946. And this college had a nice little, well, I wouldn't say nice, had an old telescope that couldn't do too much with it. So Nancy and a couple of the other students took it upon themselves to go into the observatory, clean up this telescope, recalibrate it, and make it as good as new. She did earn a doctorate in astronomy at the University of Chicago in 1949. And just a little history about NASA. NASA was created by Eisenhower after signing the National Aeronautics and Space Act in 1958. NASA was in operation in 1958, October 1st. And in 1959, an employee of the 6-month-old fledgling NASA asked Roman if she knew someone who might be interested in creating a space-based astronomy program. Well, Nancy thought about it for a split second and says, yes, I know someone, me. So she was the first woman to hold an executive position at the National Aeronautics and Space Agency, now called administration. She was the chief of astronomy and relativity throughout the 1960s and 70s. And at this time, there was a pretty difficult era for women who volunteered to wanted to advance in scientific research. Even college professors didn't think women should be involved with astronomy, but Nancy proved them wrong. And she was treated as an equal at NASA. Even though in the beginning she could not get past the secretaries without stopping to explain her credentials, and even at one point she had to use the prefix doctor in front of her name. She created the NASA Space Astronomy Program, and a lot of her duties involved getting grant funding for the different missions. She liked talking with scientists to learn about how NASA could help them, and then she would go from the scientists over to the engineers to say, is this even possible? And projects that they were working on, if there was a project that wasn't going any place, she would stop right away and concentrate on the projects that were making progress. Over the next 2 decades, Roman devoted herself to getting funding and approval from Congress for what would become the Hubble Space Telescope. A little bit about the Hubble. It was conceived in 1940. The funding was actually approved in 1978. And it was because of Roman's tirelessly advocating for new tools that would allow scientists to study the universe, which led to the launch of the Hubble Space Telescope in 1990 on its 15-year mission. Nearly 20 years after she started at NASA, Congress approved the mission, leading to her nickname, the Mother of Hubble. And talking with Congress, she would share that for the price of one night at the movies each year,
Each American can receive 15 years of exciting discoveries. Well, she was almost right. Each American now received over 30 years of those discoveries. And here's a picture of Nancy Grace Roman at the Goddard Space Flight Center in Greenbelt, Maryland in 2017. And this is the logo for the Nancy Grace Roman Space Telescope. And I'll go into a little bit more detail what that pattern is and why it's very important in this type of a telescope. And here's Nancy with Buzz Aldrin, the second astronaut to walk on the moon. The Nancy Grace Roman Telescope actually started out as what was known as the W-FIRST telescope, which stands for the Wide Field Infrared Survey Telescope. This started in 2010. And to compare it, Nancy Grace Roman uses a wide-angle lens that covers a very broad patch of the sky, where the James Webb Space Telescope has a very narrow and detailed field of view. The telescope is going to be placed in the so-called Lagrange points, and these are locations in space where the gravitational forces and the orbital motion of a body balance each other out. Therefore, the spacecraft can basically hover and not use as much energy. Nancy passed away on December 26th in 2018 at the age of 93 in Maryland. And in May of 2020, 15 months after her passing, NASA announced that the next flagship mission would be named the Nancy Grace Roman Telescope in her honor. And the Goddard Space Flight Center in Greenbelt, Maryland is handling this mission and the operations of the Nancy Grace Roman Space Telescope, which is scheduled to launch in May of 2027. As of July, $4.3 billion was spent on this, which was previously $2.9, but the cost increased because of COVID delays. Compare that to the Webb telescope, which was $10 billion, mainly because of its size and the unprecedented testing before launch. And comparing that to Hubble in 2021 dollars, Hubble would have been $16 billion. So if we take a look at the Hubble Telescope field of view, you can see it has two sensors, 2048 by 4096 pixel sensors. Comparing that to the James Webb, which has 8 sensors, 2048 by 2048. And back to that logo earlier where we saw the Nancy Grace Roman Space Telescope. This is the size of the field of view. 18 sensors, 4096 by 4096 pixel sensors are being used. Both the James Webb and Hubble are reflecting telescopes, and they reflect light off large mirrors onto a secondary mirror, will lead it back through a hole in the primary mirror and into instruments for analysis. And we'll talk about those instruments in a little bit. Most telescopes fall into one of these 3 categories: refractors, reflectors, and kind of dioptric or compound scopes. And the field of view refers to the area of space that the telescope can observe at one time. So if we're taking a look at what the different telescopes can view, you can see the Hubble, the white area where it says Hubble, Roman, and Webb. If you go up to the chart above the colors, you can see that the Hubble starts in the ultraviolet and goes to the beginning of the infrared, where the Roman starts in the middle of the visible spectrum and goes a little bit further into the infrared, where the Webb telescope pretty much starts at the infrared and goes a lot deeper. They are both optimized to work on the wavelength range of the infrared, but the Nancy Grace Roman will cover a very broad patch of sky. And you got to figure that these two telescopes are both different, and thus the coverage has to adapt to their observational needs. Each telescope is intended to complement the others. So here's a comparison of the Nancy Grace Roman Space Telescope compared to the Hubble Space Telescope. And in 2011, NASA received a phone call from the National Reconnaissance Office saying, hey, we have a couple satellite mirrors up in upstate New York. You want them? And right away, NASA said, sure, we want them. These mirrors had some state-of-the-art components and had to be retrofitted. And a lot of the instruments were intended for covert affairs. And one of the stipulations from the NRO was that these new mirrors cannot point towards Earth. It might reveal too much about the classified origin of the spy satellites. There's still no plan or funding for using the second mirror at present, but that might be a good speech for someone else to cover when they do come up with that. So here's an image of the Nancy Grace Roman Space Telescope. Its 5-year mission with a 10-year goal, set to launch in 2027 from Cape Canaveral in Florida aboard a SpaceX Falcon Heavy rocket. The Nancy Grace Roman is designed to explore questions regarding dark energy, exoplanets, and infrared astrophysics. Its primary mission is to investigate dark energy. And this is the name we give the mysterious influence driving the accelerated expansion of the universe. And the broad field will make it easier to see the expansion and better understand it. Other objectives of this study include supernovas and examinations of objects in the outskirts of our solar system. The first year of the 5-year of observation, the Nancy Grace will image 50 times as much sky as the Hubble did in its first 30 years. The Roman will look at billions of cosmic objects to explore how planets, stars, and galaxies form and develop over time. My daughter actually got to visit the Goddard Space Center clean room in Maryland, and it's pretty amazing the size of this place. It is huge. And these two images are the clean room. The panels on the wall that you see are actually HEPA filters to filter out any dust particles. Even a small amount of dust can influence the precision of the instruments and the accuracy of the measurements while out in space. This room gets air cycled every 60 to 90 seconds, and everyone that goes in here has to wear a special white suit that they call a bunny suit. And you can see that guy in the picture on the left side. If you take a look at it, it does look like an oversized bunny, so that's why they call it the bunny size. Once a person is fully gowned up, they can proceed into this clean room. You're not even allowed to wear deodorant in this room. That's how clean it is. The test areas can mimic the vibrational models of the launcher. Vacuum chambers can mimic space conditions. And the test room tested the aperture cover a few months ago, and everything worked great. And right now, they're really progressing a lot more on putting the space telescope together. So a little bit about the mirror. The primary mirror is a 2.4 meter or 7.5 feet tall, the same as the mirror in the Hubble. It's made of a special material called ULE, which is an ultra-low expansion glass. It's material that will not expand or contract very much. It's not your normal mirrors. The advanced materials need to be flawless in order to function properly, on top of needing to survive the harsh conditions of space. Even a scratch 1/10,000th of an inch the size of a human hair can make it inoperable. The mirrors use a protective silver rather than aluminum, so it's gone through quite a bit of light gathering ability compared to the Hubble, which is basically 10 to 6 or 6 to 10% more light gathering capabilities. The layer of silver is less than 400 nanometers thick, about 200 times thinner than a human hair. And because of the 30 years of advanced technology, it's a quarter the weight of the Hubble mirror. The secondary mirror is only 22 inches, and it has 3 vanes on it. And these vanes are adjustable so they can adjust the location of that secondary mirror. And Nancy Grace Roman has a 12 spike pattern due to the struts holding the secondary mirror. And so now if you ever see an image and you can see the star spikes, you see 6 spikes, you know it's coming from the James Webb Space Telescope. If you see 12 spikes on the stars in a new image, you know it's coming from the Nancy Grace Roman Space Telescope. So the main objective is to discover and learn about dark energy. We know that it's the expansion of the universe, but nobody knows why or how. And hopefully Nancy Grace Roman and its new capabilities can help lead us to an answer. Exoplanets, using a quirk of gravity known as microlensing to help find exoplanets, which is a planet outside the solar system. And there's some microlensing, the universe's own magnifying glass. As an exoplanet passes in front of the star, the background light brightens due to gravity. Gravitational lensing is an observational effect that occurs because of the presence of mass warps the fabric of space-time, much like the dent of a bowling ball makes when set on a trampoline. Its discoveries are also going to include other cosmic mysteries. 3D maps will help scientists to see patterns in the growth of the universe and distances. Nancy Grace Roman will also measure shapes and distance of other galaxies. The instruments on board to help us do all this is the wide field instrument and the coronagraph. The wide field instrument is the key feature, and it is a 300 megapixel camera with an 8-position filter wheel and an 18-panel focal plate. The coronagraph, the second instrument on board, eliminates light glare. It consists of rings, masks, sensors and filters, and formable mirrors, which uses pistons to form these mirrors to help the light be a lot better. The first time using formable mirrors in space, they're using them now on the ground telescopes, but this is going to be all new for trying this out in space. And this coronagraph will only be used during the first year, but hopefully future scopes will start using these formable mirrors. And so if we take a look at how does 300 megapixels compare, well, 10 to 30 megapixels for photography, a 4K equals 8.3 megapixels, and 12 to 50 megapixels typically in a phone. Yeah, some of the Galaxy new phones are using 200 megapixels, but that's using binding, and the actual camera is only 12 megapixels. My camera that I use, the ASI 533 MC, it's only a 9 megapixel camera. So the structure, the size of the mirror, and the precision objects is what gives the Nancy Grace Roman the best imaging possible. The barrel-like shape of the spacecraft blocks out unwanted light from the sun, and for optimal performances, the sensors must operate at a minus 288 degrees Fahrenheit. The infrared imaging is used to measure the temperature of an object, and infrared waves have longer wavelengths than visible light and can pass through dense regions gas, and dust. And by using spectroscopy, we can see colors which are emitted or absorbed, and astronomers can identify the chemical composition of a star's atmosphere or an interstellar nebula. This is also used to measure the distances to galaxy. And the best way to get this story was to reveal the spectra of every galaxy in image all at once. So being a wide field imaging photograph, you'll be able to see a lot more at one time. Again, it does use a wide angle lens, and the data that it's collecting per day compared to Hubble, which is only 2.7 gigabytes, the Webb gathers about 58 gigabytes per day, but the Nancy Grace Roman is going to gather 1,375 gigabytes per day sent to Earth. A good thing for cloud storage. Because of this, we can access the data, and the statistics, the more data, the better. The Roman Grace Space Telescope Science Operations Center at the Space Telescope Science Institute is responsible for data processing, and you, the science community, can also download this data and process it yourself. The Space Telescope Institute, the same place as the Hubble data processing in Baltimore, Maryland, had employed 800 employees in 2021. And just to let you know, the transfer takes 5 seconds to send radio signals despite its location 1 million miles away. So how does it work? Well, the aperture, the size of the open, determines how much light enters the camera and image sensors. Curved mirror that focuses the light reflects it back to the secondary mirror, which sends the light to one of two instruments, the wide field instrument or the coronagraph instrument. Adjusters and focus and filter the light before reaching the focal point panel. And the filter wheel, which allows for different wavelengths of light to pass through. It uses 8 different filters based on what the researchers studying at the time. It creates an image on the 18 sensors, and these sensors are what gives Roman its wide field of view, creating that 300 megapixel imaging using the photoelectric effect, which does the conversion of photons to an electrical signal. Then it gets decoded into an image by a special software. And compared to Hubble, which had first generation chips in the late 1980s, the Nancy Grace Roman is now using third generation chip sensors. And the James Webb Space Telescope will follow up on what Roman discovers and finds the most interesting discoveries in this broad field. The James Webb will now narrow it down and get some more data. So if we take a look at how it works for the wide field, you can see the light coming in, the 2.4 meter aperture, the main curved mirror, and the other mirrors to adjust the light beams, the element wheel, and the focal plane assembly. So if we take a look at an animation, you can see the light coming in, being bounced off of the primary to the secondary, getting adjusted through the filters, going through the filter wheel, onto the image sensor, which is then decoded and creating an image. Now the coronagraph is roughly the shape and size of a baby grand piano. Its adaptive optics, so to speak, allows it to harness that light through a series of discs and masks. Think of it driving down a road on a sunny day and the sun's out in front of you. What do? You put your hand up, block the sun, and you can see the road a lot better. So think about the light coming in and putting special masks and blockers in that wavelength of light to be able to enhance it and see what you really need to see. Nancy Grace represents a technology breakthrough that will revolutionize the search for exoplanets. And this is where Bob Tremblay is going to get all excited, because in December 19th of 2024, we had 5.8 thousand planets discovered. And within 10 years of Nancy Grace, in the next 10 years, there's going to be an additional 100,000 exoplanets being discovered because of this technology. It works by blocking light from a bright object, such as a star, so that the observer can see more easily see a faint object like a planet. By blocking the light, you can also see much dimmer light. And kind of like, we saw in the eclipse that happened, where the moon blocked the sun, we were able to see some objects behind the sun. The normal coronagraph will show the main light plus disk of light known as diffractions, but the main disk will block light. It's kind of like a washer that will block, put in the path of that light. The James Webb and Hubble Space Telescopes, by contrast, use passive coronagraphs that cannot change or adapt once they are operating. This demonstrates for the Nancy Grace Roman technology to eliminate the glare of nearby stars and directly image planets in orbit around them. And it's designed to detect planets 100 million times fainter than their stars, or 100 to 1,000 times better than existing space-based coronagraphs. And you can see the formable mirrors will actually control that light coming in and giving it a much steadier path. It blocks light, the light of stars inside the instrument, so that objects close to the star can be observed. But it doesn't block the starlights with an opaque disk as a simple coronagraph does, but uses a combination of disks with complex patterns and light blocking stops to create destructive interference with the star's light, affecting its making it disappear while allowing the light from planets to pass through. Kind of picture, a swimming pool and something painted on the bottom of the pool like a school name, and the letters look crisp and easy to see when the pool is calm, good seeing. But now that swimmers go in and do cannonballs, that ripple of the water and the reading of the letters at the bottom of the swimming pool are kind of hard to see. And that's where this formable mirrors will take an effect and enhance that light beam. The distortion picked up the mirrors will need to be corrected, and that's what helps out. It cancels the effect of bad lighting due to the mirrors. The coronagraph has special formable mirrors, a technology breakthrough that will revolutionize the search for exoplanets. And you can see here the coronagraph mirrors en masse, and compared to the size of the hand, how big those things are. And if we take a look at the primary mirror, you can see the person standing there. That's, pretty amazing piece of glass there. And here's another picture, just for reference, of the mirror itself. And you can see the wide field sensor focal plane references the size of it. You can see the guy's hand holding that plate up and how large that is going to be. And here's some latest pictures of the Nancy Grace Roman Space Telescope being constructed. And these were just taken less than a month ago. So they're making a lot of progress. So the wide field instrument sensor plane Each of the 18 sensors has the 4096 by 4096 pixels. And why the unique pattern of sensors? It's the design so that it minimizes aberrations over a wide field. That is, aberrations cause the image formed by the lens to be blurred or distorted. So you can see some of the notes on the slide. I'm not going to read everything, but there's, talks about the technology of the sensors, what type of sensors they are, how many arc seconds, core of Roman's camera. And you can see that compared to a full moon, a diameter of 0.5 degrees or 30 arc minutes, and the array of these sensors will capture 0.28 degrees field of view or a resolution of 0.11 arc seconds. Using this instrument, the Roman image will capture a patch of sky bigger than the apparent size of the full moon. And the Nancy Grace Roman is 100 times faster than Hubble. And here you can see the Hubble, that little white square in the center of what it can see at one time, where the outside white lines are from the Nancy Grace Roman Space Telescope in the field of view that it can see during its viewing session. So if we take a look at, the moon with 0.5 degrees, then Andromeda, 180 arc minutes. It would take the Hubble 432 images to image M31, the Andromeda and the moon, where Nancy Grace Roman would only take 2 images to image the M31. And the focal plane array captures the 0.28 degrees field of view with a resolution of 0.11 arc seconds. That's pretty amazing. If we were to compare that to some of the telescopes that we have, by the numbers, a reflector being versus a refractor, overall length, the 2 position, one being in LaGrange, one being in, Rochester, Michigan, or the tube length, average 714 millimeters compared to their focal length, the camera sensors, the pixel size, and the field of view. The bottom line is the amateurs get smoked. The 0% light pollution, a huge mirror, 18 sensors equals a large field of view and very fine resolution. All this equates to the new best-in-class images. Oh, thank you. Hopefully you learned a little bit about Nancy Grace Roman and a little bit about the Nancy Grace Roman Space Telescope. Any questions I can answer?
It's located at one.
Yeah, hold on 1 second. Can you hear him?
Yeah, it's going to be located at one of the Lagrangian.
Yeah, L2.
L2.
Yeah.
Repeat the question.
He was asking, Angela was asking where the telescope was going to be located. He was confirming it was going to be at the L2 Lagrange point.
Yes, it is. That's correct.
Pardon me?
Webb's at 2 also.
Webb is at Webb is at L2, right?
Yes,
That's
it is.
behind.
They're both at the same location.
That's on the other side of the moon, right?
Yes.
Bill, I have a question. Can you hear me?
Yes, go ahead.
So the 18 array camera sensor seems to be in an odd shape. Did you read any reason why it's that way? I'm guessing it's just the way it's packaged in there.
No, it has to do with the way the light coming in, the aberrations of the pattern, to way it reads it. If it wasn't in that shape and they were all side by side, it would come in too fast and it would lose a lot of its capabilities. So that the way it's angled and configured is what allows it to get the best optimum lighting based on what's coming in and hitting those sensors.
Okay, thank you.
Yeah, it's actually called a thing called offsetting the SCA columns, which is the sensor chip assembly, is the SCA. And its layout follows the natural annular curve of an off-axis TMA 3-mirror anistomatic optimized field. So that's the technical jargon for that part.
I have a question. I'm sorry, I may have missed it. What is the service life of the telescope?
It's a 5-year mission. It's designed for 5 years. They're hoping 10 years. But if it's anything like Hubble, it's going to go a lot longer. But it's a 5-year mission, with the first year being only the coronagraph and the other after that being the wide field instrument.
Okay, thank you.
I have a question as well.
Yes.
During the Hubble, when it was first manufactured or fabricated and then launched, we found out that there were some problems with the figuring of the mirrors, and had something to do with them being figured here with gravity and so on. How are they making sure now that optics like this will not have a similar problem?
30 years of technology. The difference between back then and now has greatly improved. The technology has caused the weight of the Nancy Grace Roman's telescope to be a quarter the weight of the Hubble Space Telescope. So the technology is basically the answer to that.
Okay.
There are new improvements.
Comment.
Question?
One comment about that.
Mm-hmm.
I think it not only has the technology for testing a telescope that they're going to put in space greatly improved, but NASA was so incredibly embarrassed when they launched the Hubble telescope that for 2 years they couldn't really hardly see a thing with it, that they test the living daylights out of these new telescopes to make sure they don't wind up doing something incredibly stupid again like they did with Hubble.
Oh, yes. That clean room in Maryland has a lot of extra rooms in it where they can, and because of the James Webb, they built a lot of these rooms for the extensive testing, and they can put these scopes in these rooms and test those environments which they never had before. So yes.
Well, the program for this telescope coordinate with the Vera Rubin telescope program.
Can you repeat that again?
Will this telescope coordinate the program, its observing program, with the Vera Rubin telescope or observatory, the LSST program?
I haven't heard of that specific program, but I know the center that's monitoring a lot of this data is going to be the same center that's monitoring the other data, and all that data is going to be available to us. So it's going to be available for sure.
Thank you.
All right, no more questions? All right, let's give a hand to our speaker.
Yep,
Thanks
thank
a lot.
you for allowing me to do the presentation. Thank you, Dale, and thank you, Warren Astronomical League and Society, and all the guests and everyone else. Thank you.
All right, thanks, Bill. All right, so our next star party is January 25th. Our next board meeting is in 11 days, January 27th. We meet afterwards at the Coney Island for gastronomy and astronomy, and join us there. Clear skies, everyone. Good night.
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 See what he wants to do with all this.
Can I get a copy of the lecture?
No, it was, he gave it online.
Oh.
I don't have it here. Sorry.
It's all right. Remember I told you.
You're gonna take all this?
I can.
Yeah.
If you would.
So posted on YouTube.
Yeah.
Be there within 5 minutes.
Oh, okay, you'll upload it right from there. Okay, gotcha.